Okay, I think it's time to start. Well, this is the original title of the conference, but I like to think a lot about the subject of my conferences, my few conferences I've done so far, and I usually use cinema as an inspiration. So thinking about the subject of this conference, there are two important things. The first one is there's a misunderstanding in the sense of what means temporal tables. Usually in databases, temporal tables are tables that are created for any specific purpose, for example, creating an index or doing a sort or things like that. But there is another concept of temporal tables, is tables that take into consideration the time, okay? So for example, if you store information about time, you are using temporal tables. So the second thing is that, as I said, I like very much thinking about cinema and things like that. And a short story came to my mind about the subject of the presentation. And I was considering changing the name to Do Databases Dream of Electric Tables. I don't know if you know the joke where it comes from. It's obviously Blade Runner. And one of the most iconic moments in Blade Runner is the famous scene, Tears in Rain, when one of the replicants says the following words: I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watch sea beams glitter in the dark near the Tannhäuser Gate. All those moments will be lost in time like tears in rain. Time to die. I don't know if you know that the guy who wrote these exact phrases is the actor. It was not part of the script like this. He decided to change. Actually, nobody knew that he was going to say these words. And they said, okay, that's it. You nailed it. That's perfect. This is the original one. At the first versions of the script, it was like, I've no adventures in places you people will never see. I've been off-world and back, frontiers. I've stood on the back deck of a blinker bound for... It's like lots of techie text. And this was one of the versions, the first versions of the script. And this was the real version that it was supposed he had to say. I've seen things you little people wouldn't believe. Attack ships on fire off the shoulder of Orion, bright as magnesium. Rode on the back decks of a blinker and watched sea beams glitter in the dark near the Tannhäuser Gate. All those moments, they'll be gone. I want you to watch the scene because it's quite impressive how a small change in a script I don't know, I think we don't have the volume. It loses a lot if we can't hear it, so... No, I don't remember the text. Well, I think you all know the story, what's about, and Roy Batty is going to die, so he explains that all the things he has seen are things that will be lost in time. I guess all who have seen this movie like it very much. I'm not going to ask you how many of you have implemented replicants in production, but I suppose some of you have seen the movie and think it's a great movie. Well, there's a small problem with this movie. Which one you like? Because there are a few versions of... Stop the video. There are a few versions. Ay, hombre. There are a few versions of the movie. So actually there are 6 or 7 versions, different versions. So if you like the movie, I would like to know which one you like. The first version of the script, the real version of the script, with being part of the director's cut, or the final cut, or do you really think that the original, the preview version, was the good one that was changed because the producers thought that the movie was not good enough? So the thing is that the script was alive and was changing over time, and the movie itself was alive and was changing over time. Things are not immutable. Things are not permanent. Things are created, modified, and removed or updated. So databases, it happens the same. The data we have in a database changes. We tend to see databases as like, the information is permanent, and it's not true. The information we have in a database tries to mimic the real world. But how we mimic the real world? Using columns and rows. So it's not, we are losing all the, if this table was the script, we would have only one version of the script, okay? So the thing is that we need to add some extra dimensions to the databases and to tables. How can we do that? Well, there's a way. You bring your 3D glasses, and then, but this way it's not actually the right way. Obviously, I'm joking. There was, for a long time, there were discussions about how to implement time in the database. And finally, with the standard of 2011, they reached an agreement to add some temporary features to the SQL standard. First of all, they created something, they added something called periods of time. And a period of time, what defines is the validity of that data during that period of time, during the beginning and the end of the period of time. And also, they described, or they defined in the standard, 2 types of time management within the database. The first one is system version, also called transaction time, that is automatic. And the second one is application time, also called valid time, and is application-oriented. What is the difference? The first one is the script. We've seen that there are 7 versions of the movie, but we just had one version of the script. That was the one that was used to film the movie. We don't have any version of any of the 7 versions of the movie include the dialogues of the first version of the script. Okay? Application time data is instead the number of versions we have of the movie. We can buy several versions. Actually, probably if you look for the gold box with all the versions and pictures and all the stuff, probably you have DVDs or Blu-rays with each and every version, okay? So in this case, you can decide which version. In this case, there's one version that is good, and the others can be verified or seen, but are not part of the movie. And there's a third option that is adding both types of temporality to data. MariaDB implemented system version support in 2.3.4 and in 10.3.4, and application time support in 10.4.3. I guess it was not intended to do the switch of numbers. 10.4.3 was released as 10.4 was released as general available recently. And one disclaimer: I'll be covering only InnoDB support for temporary tables. Okay, I had no time to check if the behavior of other engines, and as InnoDB is the most frequent engine used in MariaDB, I think it makes sense to cover it. So let's see system version tables. Here we have a sample table. It's nothing special. You have a primary key, integer and character values. Contents are no mystery also. So we have something called the simplified syntax that allows us to add system versioning to a table. It's quite straightforward. Alter table, add system versioning. No complication. But what does this? It's also possible to create a table with system versioning. So you don't need to add it later. It's also one option when creating a table. So let's say, for example, we have our table is system version. We insert data. That's fine, no problem. But what happens when we update data? We are updating one row, and we see rows matched 1, changed 1, inserted 1. I'm just updating. Why is it inserting data? We look at what's in the table, and we see the row we inserted previously and the update have been executed. But we have another option is, let's see the content for all the system times. And here we see that we have the row we inserted, we have the row that was inserted at the beginning, and we have the row updated. We have all the history of changes in the table. It is also possible to see a view of the table at a specific time. So for example, if I do select star from the table for system time as of, forcing it to be a timestamp, and I see the data in the table at that specific moment of time. And I can also use intervals. Intervals are a bit complicated. You need to think as you will see all the valid versions of the table during the interval. So if a row was present at the table during the interval, you will see it. Okay? This doesn't mean all the rows changed during the interval. You will see rows that were present previously because during the interval the rows were visible. Okay? Catch it? Okay. And if we remove rows, we again see that the deleted rows are stored also within the system version table. The question is, okay, so now we know that this information is stored within the table, but where is this information stored? So we look at the table definition, and we see there are no extra columns. We just see the ID, the integer, and the text column. So let's make sure, because maybe it's the engine who is storing the rows, and we are not seeing it. So we go to the information schema tables, and here we find that there are two extra rows, one called row start and the other one called row end. And one thing interesting is that we've seen in the primary key we have row end also. Okay, so we see with system versioning actually changes somehow the structure of the table. Well, let's try to find more information about what's written in those two columns. Well, we can specify the columns, and then we find information. If we use it normally, we will see that all the columns have the same row end, and this value is the maximum value for a timestamp in MySQL. So before 2038, we will be safe, but after that, all our timestamps, this is the 2000-year syndrome for timestamps in MySQL. And if we do a check for all the information that was present in the table, now we see something interesting is that we have the row end has changed. So what row end and row start defines is the life of that version. When the version was born is row start, and when the version died is row end. So for current rows, what we have is the max value. It's like immortal. Okay? So when a row is deleted, you just need to update the row end to the current timestamp. But if a row is updated, it's almost the same. What you do is inserting a new row and updating the older with a row end. Okay? Here we see row start is the timestamp of the row insertion or the previous version of that row, and row end is the timestamp of the row change for that modified row or max value for rows that are not changed. And also the primary key changes, row end is added at the end of the primary key. Well, let's recap. What does MariaDB do by adding row end to the primary key? Well, what they are doing is they allow us to have different versions of the same row. So internally, it has to filter this somehow. And the filter is adding the condition of max value for the second column of the index. So if you do an access based on index, you will access using the, based on primary key, you will access using the primary key plus the max value of timestamp that we know is the value for the rows that have not changed. Okay? So for primary key access, there's no problem. We just add one extra data to the filtering, but there are some considerations. The first one is we are reducing the available size for primary keys because we have a few bytes, not much, but we have a few bytes extra. So I don't know if you've seen sometimes you have to work to have a primary key smaller because it does not fit. So we have to consider that it's possible not to be able to add versioning because the primary key is big enough to use all the space. Another consideration is that all versions of a row are kept together because we have the IDs. So if we look at the page stored in this, we will have ID 1 with row end, ID 1 with a different row end, ID 1 with a different row end, ID 1 with row end max value for a timestamp. Okay? How can we fix this? We can fix this using partitioning. This is something we will see later. And another consideration is we are going to use a lot of space. Okay? And using more space can make things worse in terms of your working set will be larger, certain access patterns will change for sure. Another interesting thing is what's the performance of querying old data. So if I run the query, for example, for a specific time, I see that there are no possible keys. I have to do a full scan. So if you plan to use system version tables, you need to add one index for row start and row end. If you add the index, then both queries have the possible key and they actually use it. How does this replicates? Okay, because from now on we've seen that it looks that it should work, but now we must know if also this is going to be replicated properly to other servers, and the answer is it replicates fine. If we use row-based replication, it would sorry, it will replicate using the timestamps properly, and if we use statement-based binlog, as we have the set timestamp, we will use also the right information, just because every time we modify one row, we use we need just to know one timestamp. This is current timestamp. The others are or the end, or the original end, or the future, no, the original start or the future end. How to remove system versioning? It's very easy. Alter table, drop system versioning. It's also possible to purge or remove part of this historical data. You can delete completely the historical data, or you can just delete before a certain moment in time. And now we are going to see the extended syntax. This is the syntax defined by the standard. The syntax defined by the standard has the start and end timestamps. And then we say that we define a period for system time using these timestamps. There's an option, one option used twice, invisible. This is not required. You can create the table without the invisible, but then each and every query will need these columns. So you need to insert with null or specify the columns, that select the star will show these columns. Okay. So if you make these columns invisible, the table works normally as usual, but you have these extra columns. One thing you have to know is that if you use the extended syntax, dropping system versioning involves also dropping the columns, because these columns are generated. So it's not enough just to remove system versioning. You have to remove system versioning and the columns at the same time. Partitioning. How can we partition these tables? It's quite easy. We can have, for example, two partitions, one for the history and one for the current table. And it's as simple as alter table, partition by system time, partition for history, and partition for current data. We can have multiple partitions, limiting the number of rows in the history partitions, or using intervals. So every week it changes. What happens if you forget to add partitions? Nothing. The last partition is used. Okay. There is an extra feature implemented in MariaDB called transaction precise history. Why do we need transaction precise history? Well, the problem is that, well, it's great to know at what time something happened, but this information is not enough to understand what has happened. First, because the timestamps are not transaction-wide, but sentence or change apply for different changes. So if I change 3 rows, I'll have different timestamps for each row. Okay? If it's the same insert, for example, I insert 3 rows, they'll have the same timestamp. But if I execute 3 inserts, they have different timestamps. Okay? So when I go to the history to look at what has happened, I have no way to know if these 3 changes were processed by the same session or the same connection, because I only see the history. That row changed at that time. Yes, I know that row changed half a second later, but this is not a proof of being part of the same change. So this feature, instead of storing the timestamp, what it stores is the transaction ID. Okay, so we have the start transaction ID and the end transaction ID. What is the start transaction ID? The ID of the session that created that version of the row. What is the end ID? The ID of the session that made that row obsolete, either because it removed the row or because it replaced the row with another one. Okay? So here, for example, we see in a transaction table, we see that this was the start transaction, and again we see this end transaction. Well, this is the max value for integers. So again, it's the same than timestamps. If this is such a large number, this means that this is the active column. This means also that it's implemented the same way. It's adding the transaction ID to the end of the primary key. We can query history by transaction ID. That's fine. We have this information in the primary key, so it's not that difficult to query that. But there's also something that is quite interesting. We can still use timestamps. But we don't have timestamps. We have transaction IDs stored in the table. And it works. So I'm seeing that timestamp. So how is possible to know the timestamps if they are not on the table? Well, because they are stored in a different place. So we have, in the MySQL database, we have a table called transaction registry. The transaction registry has the transaction ID, the commit ID, the begin timestamp, the commit timestamp, and also the isolation level of that transaction. Okay. This table contains information affecting only tables system version. So you don't have all the information, each and every transaction that's running. You only have the information of transactions that change the table. One thing you have to consider is that you will need to purge this table from time to time because it's an extra layer of stored information. Okay. So how we can do the magic of recovering information based on timestamps? Well, we have here the timestamp of the change. So we just need to join with this table, and that's what the database does. Problems with transaction precise. Well, the main problem is that replication is not reliable. I can imagine, I'm not sure, but I can imagine the reason why they do that. They switch the binlog format to statement. They ignore, if it's row-based, they ignore it completely and switch to statement. Thus, an additional side effect of doing this is that the change will be performed at the slave using different transaction IDs. Okay? The reason to do this is, I think, we are not replicating the transaction table because it's in the MySQL database. And as we are not replicating the table, we can transfer the information from that table to a slave without changing, for example, the binlog format. We could, but we would need extended binlog format that supports system version tables. Now we are going to see the most recent feature, application time period tables. This feature is, I would say it's not beta, but it's not fully implemented as expected, but I think it's quite interesting because it opens a wide range of things that can be done or we will be able to do in future versions. How is our application time period tables defined? Well, we have to specify a period, initial and end date, and we have to say that this period is how this period is defined. Why we do that? We need to do that because this is application periods. So the database has no way to know, for example, the validity of a tax that was created in 1983 and was changed in 1985. So we would have that tax with an initial date and an end date, and the same tax with a different initial date and different end date. In this case, if we check, we see there are no hidden columns. We load some data to the table. Something interesting is that we can have overlapping periods because there's no integrity check in periods. Okay? And one side effect we will discuss later also is that primary keys and periods are not bound. So for example, I can't have a row with ID 1 that was valid last year and one row with ID 2 that is valid this year. Okay? This is defined in the standard as a feature because actually it makes sense to have, if we are considering that each row it's an entity that can be split in periods. It's not the same that saying that each row is an entity by itself. So the purpose of adding time period is to, let's say, we have 7 versions of Blade Runner. Okay? We don't have 7 different movies. We have 7 versions of the same movie. In this case, Blade Runner should be the primary key, let's say, and then we have the periods of validity of each version that actually could or not overlap. In the case of taxes, for example, it makes no sense to have taxes overlapping. You can have, let's say, a VAT of 13 and 21 at the same time. Okay. Okay, thank you. We can delete periods, and what's interesting of this approach is that deleting periods, what it does is deleting periods, not deleting the rows that fit in that period completely. Actually, it does. If the row fits in that period completely, the row is going to be deleted. But if the period where we are deleting, let's say, for example, I have a period like this, and I'm deleting a period like this, I'll have still this period. So if you remember, in the initial table, we had 5 rows, and after deleting periods, I have 7 rows. And as I deleted the period, for example, for these rows, I generated a split because I deleted a piece of period that was smaller than the total period. Okay. One side effect also of not supporting primary keys is that my primary keys changed. Okay, so it's well, if you look at the binary logs, this removing a period is implemented as I think this was, not sure if it was 3 instead of 4 updates or something like that. Okay. It is also possible to update tables for a period. And if the period does not fit completely the table, then the rows will be splitted again. Okay? Features not implemented currently. Queries using periods. This is part of the standard. We should be able to do queries like this. Non-overlapping periods, we should be able to say, okay, this is a tax table and periods should not overlap. Primary key support, foreign key support, and period columns are not indexed. You have to index yourself. So some of these maintenance operations for large tables can take a long time if you do not add the proper indexes. Bitemporal tables. What are bitemporal tables? Well, tables that have system versioning and application time periods. That is it. Thank you very much. And now I'm going to do what everybody does at the beginning. My name is Pep Pla. I was born in Binlogic, blah, blah, blah. It's me in the beach here in Barcelona. I work for Partitioning, a great company. One of the things, surrounded by some of the most brilliant DBAs in the world. I work for Partitioning, a great company. We have been a long time in business. We're a lot of people with a lot of clients, and that's